Have you ever wondered why we don't use uranium, a relatively cheap and abundant element, as fuel in our automobiles? That's a question that gets the wheels of curiosity turning, doesn't it? After all, uranium is less expensive than petroleum and is found in ample amounts across the globe. Plus, it's an energy heavyweight, packing a punch that leaves conventional fuels in the dust. Now, imagine this: an energy source that's cost-effective, abundant, and incredibly potent. It seems like the perfect solution to our energy needs. Yet we don't see cars zipping around powered by uranium. Why is that? It's a paradox that has puzzled many. But as with many things in life, there's more to this story than meets the eye. Uranium, despite its apparent advantages, has characteristics that make it a less than ideal choice for fueling our vehicles. Intriguing, isn't it? Stay tuned as we delve into the peculiar properties of uranium that make it an unlikely candidate for powering our cars. To answer our opening question, we first need to understand what uranium is and what it does. Uranium, a silvery grey metal in appearance, is a naturally occurring element on Earth. It's a heavy metal, meaning it's denser than many common materials, even denser than lead. But what sets uranium apart is its radioactivity. This characteristic makes it a source of substantial energy, but also makes it a tricky substance to handle. So, what's the secret to uranium's energy? It's all in the atoms. If you've ever heard of atomic energy, this is where it comes from. Uranium atoms are large, and like a tall stack of dishes, they're unstable. Given the right nudge, they can split apart or fission, releasing a great deal of energy in the process. But here's the catch: this isn't like burning a lump of coal or a tank of gasoline. When a uranium atom splits, it releases radiation and creates smaller radioactive atoms, known as fission products. These fission products can be hazardous, and dealing with them safely is a significant challenge. But let's not forget the energy part. The energy released during fission is immense. Just 1 kilogram of uranium can produce as much energy as burning over 1 million kilograms of coal. It's like packing the energy of a small star into a pebble. That's why we use uranium in nuclear power plants, where we can control the fission process and harness the energy produced. However, despite its energy potential, uranium isn't suitable for all applications. Its radioactivity, while a source of immense power, also poses significant risks. The process of harnessing its energy is complex and requires stringent safety measures. So with all this energy potential, you might be thinking, why isn't uranium our go-to fuel for cars? The answer lies in its very nature. Despite its energy potential, uranium has some significant drawbacks that make it unsuitable for use in automobiles. One of the most glaring issues is the dangerous radiation uranium emits. Uranium is radioactive, meaning it constantly releases energy in the form of radiation. This isn't a problem when it's buried deep underground, but when brought to the surface and processed, it becomes a serious health hazard. The radiation can damage living tissue, leading to harmful effects like cancer and radiation sickness. Not to mention, it can also harm the environment, causing genetic mutations in plants and animals and contaminating water sources. The technical challenges of safely harnessing this energy in a small, mobile platform like a car are also immense. A vehicle needs a power source that is both compact and safe. Uranium, on the other hand, requires heavy shielding to contain its radiation and complex systems to control the nuclear reactions. This makes it impractical for use in a car. The weight of the shielding alone would make the vehicle too heavy to be efficient, and the cooling systems required would take up too much space. But there's more. The risk of a nuclear meltdown is another significant drawback. A nuclear meltdown is a severe nuclear reactor accident that results in a reaction running out of control, with the potential of releasing dangerous amounts of radiation into the environment. Imagine if a car accident led to a nuclear disaster. The consequences would be catastrophic. Moreover, the process of refining uranium and managing its waste is an environmental challenge. It requires vast amounts of energy and water, and the waste it leaves behind remains radioactive for thousands of years. This poses a long-term risk for both people and the planet. As you can see, the risks and technical challenges of using uranium in cars far outweigh its potential benefits. The idea of a car powered by a lump of uranium might sound appealing, but in reality, It's a Pandora's box best left unopened. So, we've learned quite a bit about uranium and why it isn't used as fuel in our cars. Let's take a moment to recap and ponder on our key takeaways. Uranium, a heavy metal that's more common in the Earth's crust than silver, has properties that make it an intriguing candidate for fuel. It's dense, and a small amount can produce a massive amount of energy. In fact, 1 kilogram of uranium can generate as much energy as nearly 3 million kilograms of coal. It's also relatively cheap, making it a seemingly attractive alternative to traditional petroleum-based fuels. However, despite the allure of its energy density and cost-effectiveness, uranium isn't the silver bullet solution for powering our cars. The process of harnessing that energy is fraught with significant risks and challenges. The main issue is the radioactive nature of uranium. It releases radiation as it decays, and this decay process is what produces the energy we can use. But that same radiation can be harmful or even deadly to humans and the environment, making safe handling and disposal of uranium a critical concern. Moreover, the technology for using uranium in a car engine simply doesn't exist. Converting the heat generated by uranium decay into mechanical energy to drive a car would require a miniaturized nuclear reactor, which is far beyond our current technological capabilities. And even if we could overcome this hurdle, there are serious safety issues associated with the idea of millions of cars driving around with nuclear reactors under the hood. In essence, while uranium's energy potential is tantalizing, the risks and challenges associated with its use make it an unsuitable choice for fueling our cars. The story of uranium reminds us that energy production isn't a simple matter of finding the cheapest or most abundant resource. It's a complex process that requires careful consideration of safety, sustainability, and feasibility. While uranium may not be the answer to our energy needs on the road, its story serves as a reminder of the complexities of energy production and the need for safe, sustainable solutions.